had mistakenly wrote 2 to the power of m times square root of 1 over 4096 as 2 times mth degree root of 1 over 4096. What is the sum of all real numbers m for which these two expressions have the same value? All right, let's calculate the first expression. But we have 4096 here. So 2 to the power of 10 is going to be 1024. And if we multiply by 4 both sides, we are going to have 2 squared times 2 to the power of 10 will be 4096, which is 2 to the power of 12 is equal to 4096. Okay, great to know this value first. And let's calculate this value. 2 to the power of m times square root of 1 over 4096. If we write 2 to the power of 12, we are going to have 2 to the power of m times square root of, it will be 2 to the power of negative 12. And if you would like to take this one outside the root, we will divide negative 12 to the index, which is index is square root, which is 2. It's going to be 2 to the power of m times 2 to the power of negative 12 divided by 2, which will be negative 6. So 2 to the power of m times 2 to the power of negative 6 is going to be 2 to the power of m minus 6. On the other hand, let's calculate the second expression, which is 2 times mth degree of 2 times 2 to the power 1 over 4096, 2 to the power of negative 12. We will multiply 2 times, we will take the number outside the radical, which is we will divide power to the index, negative 12 divided by m. And now we are going to apply the product rule. It will be 2 to the power of, there's a 1 here, 1 plus negative 12 over m. So these two expressions are going to be the same value. So let's equalize these two expressions. 2 to the power of m minus 6 is equal to 2 to the power of 1 minus 12 over m. I can write, since bases are the same, we can equalize the powers. This m minus 6 has to be equal to this. All right, it's going to be m minus 6 is equal to 1 minus 12 over m. And let's rewrite this. It's going to be m minus 12 divided by m. Let's multiply m both sides. It's going to be m squared minus 6m is equal to, if we multiply both sides by m, let's show that, times by m, this cancels out. It's going to be m minus 12, and take everything to the left. It's going to be m squared negative 6m minus m negative 7m minus, it's going to be plus 12 is equal to 0. Now we are looking for the sum of the solutions for m, which is the sum of the solutions we can find from the Vieta's formula, or let's calculate the roots, which is going to be 4 times 3 is 12. Both of them are negative. The sum is negative 7. M times m. The factors are m minus 4 times n minus 3 is equal to 0. So the values for m is to be 4, or the values m is going to be 3. So the sum of the values is going to be 4 plus 3, which is 7. So the answer option C.